Good afternoon. I want to take some time now to talk about molar mass and what that means and how to do the molar mass conversion worksheet that you have in your assignments, but also to let you know that this type of problem is going to continue. We're going to see more of these as we talk about balancing equations and get into chemical reactions. So the molar mass, and sometimes you'll see this abbreviated as big M, is the amount in grams of 1 mole of a substance. And when we say a substance, we're talking here about atoms or molecules or compounds. So it's the amount in grams of 1 mole of a substance. And we get the molar mass from the periodic table. And in your course resources, you have a periodic table provided for you, and the molar mass is in the upper left corner. So if I look at, for instance, sodium, I'm going to see a number up here in the upper left corner, 22.98977. So this right here is my molar mass. That is the amount in grams of 1 mole of sodium atoms, which would be 6.022 times 10 to the 23rd atoms. That's how much mass those atoms have, and that's referred to as the molar mass. And the unit for that, so if we're talking about sodium, the unit is going to be grams per mole, because that's the number of grams in 1 mole of sodium. And typically what we do for molar mass is we round to 2 decimal places. So for sodium, we would shorten that to 22.99 grams per mole. And once we have molar mass, that's going to allow us to easily convert between grams of a substance and moles of a substance. So let's look at a couple of examples. So let's say that our problem that we're working tells us that we have 2.62 moles of zinc. Okay? And we want to know how many grams are in those 2.67 moles of zinc. So step 1, let's find our molar mass of zinc. So I'm going to go to the periodic table, and I'm going to find zinc, and I see that my molar mass of zinc is 65.39, and remember our unit there is grams per mole. Now my second step is to set up the problem, and I always start with what I'm given in the problem. In this case, 2.62 moles of zinc. And I know I'm going to have to use a conversion factor so that I can figure out how many grams I have. Since I'm solving for grams, I want grams to be on the top. And I need to cancel out moles, so moles will be on the bottom. This is where my molar mass is going to go. I've decided that my molar mass is 65.39 grams per mole. So I'm going to say 65.39 here on the top. And that's the amount in 1 mole, because that's my molar mass. So now I can cancel out moles of zinc. And I'm left with grams of zinc, which is what I'm solving for. Now I solve. And in this case, I'm going to solve by multiplying, because both of my numbers are on the top in my conversion. So I say 2.62 times 65.39, and my answer is 171.3218 grams of zinc. Now after I've solved, I need to look at sig figs. So I go up to my original problem, 2.62. That's 3 sig figs. So my answer needs 3 sig figs. So my answer would be 171 grams of zinc. My last step is to verify. And in this, you're looking at, does my answer make sense? So does my answer make sense? So I look up at what I'm given, 2.62 moles of zinc. I look at my molar mass, around 65 moles of zinc. Sorry about that, my phone rang. So I have to look and see if my answer makes sense. And when I look at what I was given, 2.62 moles, I look at my molar mass, approximately 65. So I say, okay, do a little quick math. If I have 2.62 moles of zinc and 1 mole of that has a mass of 65, then I can expect 2.62 moles of that to have a mass of somewhere between 130 and 200 grams. And I look and my answer is 171. So yes, my answer makes sense in the context of the question. The other way that we can use our molar mass, is if we're given grams of a substance and want to determine how many moles that is. So let's look at that type of example. So let's say I have 342.2 grams of mercury. And I want to know, how many moles of mercury do I have? Step 1, still the same. I've got to find my molar mass of mercury. And I do that by going to the periodic table. And I see that that molar mass is 200.59, and my unit on that again is grams per mole. Second step, set up the problem. I'm going to start with what I was given, 342.2 grams. Now this time, when I set up my conversion factor, I have to put grams of mercury on the bottom and moles of mercury on the top. This allows the grams to cancel, and I'm left with moles, which is what I am solving for. So I put my molar mass on the bottom, 200.59, and then the 1 mole on top. Now this time I have to solve, but instead of multiplication, I use division. So I have to divide 342.2 divided by 200.59. And I'm given 1.2074 moles of mercury. Now I need to look at sig figs. In my problem, I had 4, 342.2, so I had 4 sig figs. I need 4 sig figs in my answer, so 1.207 moles of mercury. Remember, zeros are significant if they're in between 2 non-zero numbers, and these are. And then my last step again is to verify. Does my answer make sense? I have 342.2 grams of mercury. 1 mole of mercury is 200 grams, so I would have about a mole, a little less than a mole and a half of mercury. And I see that, yes, 1.207 moles. My answer makes sense. So, yes, I think that I could have the correct answer. And that's the reason why we verify, just to make sure that our answer makes sense. If you do that verification step and your answer doesn't make sense, then you know that you've probably done something wrong. Now, if we look at the worksheet that you are to do, what you'll notice is that you don't have any single elements on any of these. they're all compounds. So for instance, in number 1, your compound is CaCO3. So what you have to do is actually go to the periodic table and look up the molar masses for each one of those. So let me show you how to do that. So I have calcium carbonate, CaCO3, and what I have to do is get the molar mass of each one of those. So my molar mass of calcium, 40.08 grams. My molar mass of carbon, 12.01 grams. And oxygen is 15.9994, so we just round up to 16 grams. But if you look at the oxygen, you notice something about it that you don't see with calcium and carbon. You notice this subscript 3 down here. So what that means is we have to multiply our molar mass of oxygen by 3 because we actually have 3 atoms of the oxygen. And so it's actually going to be 48 grams. Then I add up all 3 of those, and I end up with 100.09 grams per mole. And so that is my molar mass of calcium carbonate. And from there, I follow the same steps as I did with the other problems that I was showing you how to work. The only difference here is that you just need to make sure that you multiply when you have a subscript, like I did in this particular example. Hopefully this has helped with the worksheet. If you have any other questions or problems while you're working on those conversions, just let me know.